I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. As some of you might know, I'm providing guidance for the middle school students to understand the concepts in greater details so that they can solve challenging questions. This can help them to compete in any competition like Olympiad and also ensure that their graduation to high school and then to the university is smooth. Join our venture and watch some of these videos which can help you. Thank you. Hi Aryan, how are you doing?
I'm doing good. How are you?
Very good, very good. So in today's class, what do you want me to discuss with you?
So in today's class, can we discuss about trig identities and like dig more deeper?
Great, sure, we'll do that. So Aryan,
Okay.
I'd like you to, we are recording this session, so I like most of my viewers to understand what is this
Yeah.
topic about and where you are and where you want to be, right? So can you please introduce yourself?
Yeah. My name is Aryan. I'm an eighth grader and I'm doing math three, which is 11th grade math in eighth grade.
Yes. So for my viewers, he's a very bright student in grade 8. He's doing grade 11 mathematics. And we'll now discuss trigonometric identities. I'm going to keep it very simple because it is for a grade 8 student after all, correct? So there are a lot of things, I should say gaps, which are there. And we'll try to fill up those gaps. And I'm sure our 8th graders will understand this part of trigonometry. It is trigonometric identities. So, Aryan, can you please share with me what exactly type of problems you're working with so that we can straight look into their solutions?
Yeah. One second. Yeah. Oh yeah. You won't have the access if I share.
Okay,
So
so send it
I'll
on
just
chat. So I'll share the chat. Okay, you have sent it.
yeah.
Yeah? Okay, so the questions are there. I'll just share the screen with you.
Okay.
There you go. So can you see the screen, Aryan?
Yeah, I can see it.
Perfect. So these are trig identities. Secant x minus tan x sin x equals to 1 over secant x. That is our very first question. Perfect.
Yeah.
Now, uh, since you are in grade 8, let me give you some heads up upon these what is secant x and how to go about, correct? Secant x is reciprocal of cos x, correct?
Yeah.
And let me write all the reciprocal identities first. So we have cosecant x, which is reciprocal of sin x, and cotangent x, which is reciprocal of tan x. Other important things which you should know is tan x is basically ratio of sin x and cos x. Now, before getting into great details, let's take this formula also, which is sin square x plus cos square x is equal to 1. Now, sin square x plus cos square x is a very important identity which we will be using so many times. So it is worthwhile to see how do we derive this identity. Let me do this derivation right here. Okay. So let us say we have a triangle whose angle is x, right here, and the sides be A, B, and C. And this is a right angle triangle. And you know from Pythagorean theorem that a square plus b square is equal to c square, correct?
Yeah.
I could actually divide all of them by, let us say, c square this time. So if I divide them by c square, each one of them,
Yeah.
the identity remains. It's a Pythagorean identity. We get a over c whole square plus B over C whole square equals to 1. And now, Aryan, in this particular triangle, what is A over C?
A over C is just cosine
So it is cos square x plus what is B over C?
sine squared x.
So that becomes sine square x equals to 1. Do you see how easily we have shown this particular identity? So that's an identity which is always true and is called Pythagorean trigonometric identity. Now, parallel to this are 1 plus tan square x equals to 1, and that is, you will get by dividing all these terms by cos square x. You get this.
Yeah,
And then cot square x plus 1 is cosecant, oh, sorry, is not 1, it is secant square x. Sorry,
yeah,
secant square x, and this is cosecant square x. You get the idea. So these are the other two identities. So we have all the identities listed here, which we are going to use in our example. Is that clear to you?
yeah,
Perfect. So let's take
yeah,
the examples one by one. The very first one, secant minus tan x sine x is 1 over secant x. Now, what you could do here is we could write them in sine and cosine. So that is one of our strategy, writing them in sine over cosine. So secant can be written as what? 1 over cos x, right?
yeah,
Minus tan is sine x over cos x times sine x. So the idea here is when you're trying to prove an identity, start from one side. So let's say we start from left-hand side. Choose the side which is more complicated. So left side is more complicated. Well, we got here cos x as our denominator, and we have 1 minus sine x in the numerator. Sine square x, right? Because sine x times sine x is sine square x. And now, what is 1 minus sine square x? Can you tell me?
yeah. Cosine squared x.
Cosine square x over cos x. Now, how did he get cosine square x? See, it is important to see that we could actually rewrite this particular formula in two different ways. We can take sine on the other side. In that case, we know that cos square x is equal to 1 minus sine square x. And that is how this Pythagorean trigonometric identity can be used, right? And
Yeah,
from here, clearly, we could cancel one of the cosines, right? And what we get here is cos x, correct? So we get here, let me write down in red itself, this
yeah,
cos x. Now, what do we want? We want in terms of secant x. So it is reciprocal, right? So this is equal to 1 over secant x, right? So this we
yeah,
get from the very first identity which I wrote here, reciprocal of cos is secant. That means that cos equals to 1 over secant. You get the idea. So that is
yeah,
how we say, well, this is equal to the right-hand side, and we have done the first question. Clear?
yeah,
Now, how do you
yeah,
do the next question, which is 1 plus cos x over sine x equals to cosecant x plus cotangent x. So in this case, let's begin with the right-hand side. What do you say?
yeah. That's fine.
So right-hand side is cosecant x plus cotangent x. Cosecant is 1 over sine x, and cot x is cos x over sine x. So we get sine x in the denominator, right? So which is equal to sine x in the denominator as required, and 1 plus cos x in the numerator, and that is equals to the left-hand side. So we have
Yeah,
shown that the right-hand side is equal to left-hand side, and we have proven the next identity. Is that clear?
yeah.
Any difficulty so far?
No, not yet.
So the next one is secant theta sine theta tan theta plus cot theta in the denominator equals to sine square theta. So Ari, what do you suggest? How should we start this one?
By simplifying the secant theta, tan theta, and
Correct.
cosine.
Writing those reciprocal identities in terms of sine and cosine. So secant theta is 1 over cos theta, correct? Times sine theta, that comes in the numerator, and the denominator will be sine theta over cos theta, which is for tan theta plus cos theta over sine theta, correct?
Yeah,
Now, so we have cos theta, sine theta in the denominator. Let me multiply each and every term in the, I mean, both numerator and denominator by sine theta, cos theta to get rid of fractions, right? So the strategy here, let me write down here. What we are doing is we are multiplying all this by sine theta, cos theta. Is it okay? Less space here for
Yeah.
me. So sine theta, cos theta. So when I do that, then the denominator cos theta will get cancelled, right? And what I get in the numerator
Yeah.
is sine square theta, right?
Yeah.
And here we get the first term as sine square theta because cos theta cancel. And the next term is cos square theta. Does it make sense to you?
Yeah.
Because when I multiply by sine theta, cos theta cancels, sine theta times sine theta is sine square theta. And here, sine theta cancels and cos theta times cos theta will be cos square theta, correct?
Yeah.
And now, denominator is 1, and therefore we get sine square theta divided by 1, which is equal to sine square theta, and which is our right-hand side.
Yeah.
So do you see? Using these Pythagorean identities along with the reciprocal identities and the tangent ratio, which is a basic identity, we can actually prove them all, right? So let's continue the same process. Now here we have cos into cot. So let's see how to do it, correct? First step first, let us start with the left-hand side and convert them to sine and cosine.
Yeah.
So let me change the color once again. So secant theta is 1 over cos theta. So we have 1 over cos theta divided by cos theta as the first term, minus tan theta is sine theta over, well, tan theta and cotangent theta are reciprocals, correct? So we could actually cancel them also. You'll see how we can work with them. Sine theta is tan theta is sine theta over cos theta, and the denominator cotangent theta, I can write like this. Cot theta is cos theta over sine theta. Do you see that? Instead
Yeah.
of making layers as I did in the first part. So when you have division, you could also write like this. Perfect.
Yeah.
So in this case, what do you get? So that was our left-hand side. And what we get here is 1 over cos square theta, correct?
Yeah.
Minus. This is also cos square theta. And we have sine square theta in the numerator. So what is 1 minus sine square theta once again?
Cos square
Cos
theta.
square theta. You get it, right? So we got cos square theta divided by cos square theta, and that is indeed 1. Perfect. So cos square theta was a common denominator, and in the numerator, we had 1 minus sine square theta, and which is equal to cos square theta. So using that Pythagorean identity, we have shown that this is also equal to right-hand side, and therefore it is true. Clear? So I hope up till now, everything is absolutely clear. Perfect. Now let's
Yeah.
move on and solve the next two. So I'll just move the screen a bit on top. Okay, I may have to erase all this, correct? Okay, so let me just clear the screen. So I'll clear the screen and then we'll again work. Is that okay? So we are on question number 3 now. So let me just push the screen and let me clear the screen. Okay, annotate. And then we'll work. Clear all. I hope you remember all the formulas which we had written. It is very
Yes.
important to put them in your mind, okay?
Yeah.
So, yeah, so that is why it is good practice to just start fresh. Where were we? Oh, we are in question number 5, right?
Number 5. Yeah.
Okay, so let me just push this a bit more up, right? So that'll be better for me. You get more space to work.
Yeah.
Perfect. Annotate. Yeah. Okay. So the statement here is cos square y minus sine square y is 1 minus 2 sine square y, right? We want, in terms of sine square y, so what we will do, we know sine square x plus cos square x equals to 1. So from here, we also know that cos square x is equals to 1 minus sine square x. We have used it twice before, correct? So I am going to write left-hand side, in this case, as cos square y will be written as 1 minus sine square y. Is that clear to you?
Yeah.
We have minus sine square y already, correct? So we already have 1 minus 2 sine square y here. Does it make sense? Which is the right-hand side. So that is simpler, since we know our Pythagorean trigonometric identity. Clear?
Yeah.
The
Yeah.
next one is cosecant square theta times tan square theta is equals to tan square theta. So in this particular case, what you could do is cosecant square theta, you could write as trigonometric identity, or if you
Yeah.
want, we can convert to sine and cosine as you wish. So,
Yeah.
well, cosecant is what? Cosecant is 1 over
Cosecant is 1 over tangent.
sine,
No, sine.
and
Sorry.
cosecant, and tan is sine over cos, right? So
Yeah.
I'm
Yeah.
still working on these things so that you get used to the identity. Is that okay? Minus
Yeah.
1. So that
Yeah.
becomes our left hand side this time. So we get sine square gets cancelled, right? So we can now write this as 1 over, let's say, cos square theta common, right? Cos square theta
Yeah.
common. So you get 1 minus multiplying here cos square theta. Is that clear to you?
Yeah.
And what is 1 minus cos square theta? Is sine square theta
Yeah.
over cos square theta. And that is indeed equals to tan square theta. Perfect. And that is the right
Yeah.
hand side which we are looking for. So that is how you could do it. So we have till now converted all the trigonometric ratios into sine and cosine, applied the Pythagorean identity, and solved it. Do you like this strategy? Simple and straightforward. Okay.
Yeah.
Now, next one, secant square x over secant square x minus 1 is equals to cosecant square x, right? So now
Yeah.
I'm going to deviate a bit in solving the questions because sometimes we may have a better solution doing a difficult way. So I want to teach you those strategies, correct? So in
Yeah.
this case, what I'm going to do is I'm going to start with left-hand side, of course, and I will kind of divide by secant square x itself. Do you understand? So we have
Yeah.
here secant square theta, and we on the denominator we have secant square theta minus 1, and we want actually reciprocal cosecant square theta. So what I could do, I could convert to sine and cosine. That's simpler
Yeah.
for us, correct? I could do it and get the right hand side, but I'm not doing it purposely. Trying to show you that we could also do like this. We could just divide by secant square theta,
Yeah.
and we could also divide this by secant square theta.
Yes.
So in that case, what do we get in the numerator? In the numerator, we get 1. And in the denominator, when you divide, you get 1 minus 1 over secant square theta.
Yeah.
Is it okay? So
Yeah.
in that case, uh, oh, that doesn't really help because
It just makes
1
it. Yeah.
minus, it does help. 1 over secant square theta is what?
Um. Oh yeah.
1
One
minus
over
secant square theta is?
1 over cos squared theta.
So 1 minus 1 over secant is cos, right? So 1 over
Yeah.
cos square theta. Is that clear to you? Now
Yeah.
1 minus cos square theta is 1 over sine square theta. Does it make sense? And so
Yeah.
we can get cosecant square theta. Do you see how this time I have applied a different way of approaching? This
Yeah.
is not, I mean, you may not appreciate it at this stage, but it gives you a strategy. You get the idea.
Yeah.
We did not directly convert to sine and cosine, but we divided by, and then we kind of got our answer. The answer was in reciprocal identity. So I prefer to do this method. Do you like this method?
Yeah.
Looking into different approaches is another very good thing to work with. Is it okay? Now,
Yeah.
next one. Let's now think. We'll start with which side? Now we should start with left hand side, correct? We could start with any side in this particular case. Let's begin with left hand side. Tan square x times sine square x. Well, let me write this as, see, it is tan square x minus sine square x. They still maintain tan. You get the idea?
Yeah.
They still maintain tan, right? So, and you know, one of the tan identities is 1 minus secant square x. So we have this 1 plus tan square x is how much? Secant square x, correct? That is one of the identities, correct? So we could actually write tan square x in terms of secant square x minus 1. Do you see that?
Yes. Yeah.
That may give us the result faster. So what I will do here is that I will write tan square x as secant square x minus 1 and multiply by sine square x. Is that clear to you?
Yeah.
Since the right hand side is difference of two things, why not use the identity now, right? So we get here secant square x times sine square x, right?
Yeah.
So we have secant square x times sine square x minus 1, correct? Minus sine
Yeah.
square.
Yeah.
So 1 times sine square x, we already got one of the terms, right? The other term is tan square x or not? Can you check?
Yeah.
Secant is 1
Yes.
over cos, correct?
Yeah.
And this is sine square x minus sine square x.
Yeah. So
Clearly,
10.
we do
Yeah.
get
Okay.
we do get tan square x, right?
Yeah.
Minus sine square x. Do you like this idea? So this is right
Yeah.
hand side.
It's just,
We are
it's
now
just,
playing with trigonometry, right? Trigonometric identities, trying to do them in many different ways. These may not be the best ways, but since you are beginning, explore. The idea is to explore. Since when
yeah.
you get a difficult question, these strategies are going to help you. Do you like this strategy? We use this time the tan square x trigonometric identity. Clear? So I'll clear the
Yeah.
screen once again, and then we'll move forward with the examples on the next worksheet.
Yeah.
So is it the same worksheet or different worksheet? I think it's the same worksheet, right?
It's the same one, I think.
Okay. So,
Yeah. I think.
so did you
Yeah.
understand all these things which we talked about?
Yeah. We're
Okay.
basically just approaching them in like a different approach than
Correct.
like, yeah.
Perfect. Now, in addition to all this, let me clear and show you how we can very usefully use the trigonometric identities which I had talked about earlier.
Yeah.
And let me share some formulas. So I'll not share the screen now, this particular thing. I'll stop sharing this, right?
Yeah.
So we'll have a new whiteboard this time, okay?
Okay. Yeah.
So let me review what we learned today. So what we learned today is kind of like this to remember, right? So we had some formulae that is reciprocal
Yeah.
identities. Oops. Reciprocal identities.
Yeah.
So in reciprocal identities, we know 1 over sine x equals to what? Tell me.
Cosecant.
Correct. All should be written in lowercase. Is that okay?
Yeah.
And we also know that tan x is the ratio of sine and cosine.
Yeah.
We use this particular triangle, which is the Pythagorean identities. This for Pythagorean identities, we wrote this as x, a, b, and c. And we say, well, when a square plus b square is equal to c square, we could actually divide this by c square. And what we get here is cos square x plus sine square x equals to
Yeah.
1. And this particular identity is very important since I could write this as 1 minus sine square x.
Yeah.
And I'll also write sine square x as 1 minus cos square x. Does it make sense to you?
Yeah.
Now, this particular identity can also be written in many different ways. Let's say a square plus b square is equal to c square. I could this time divide by a square.
Yeah.
So if I do that, I get 1 plus b over a is tan. So I get tan square x equals to
Yeah.
secant square x. Now, same formula, I could also get another Pythagorean identity, which is dividing each by b square this time. Clear?
Yeah.
So a over b is cotangent, right? So we get cot square x plus 1 equals to c over this, which is cosecant.
Yeah. Okay.
So that is how we get the third identity, right? And now I will actually teach you another very beautiful way of working with these identities for some difficult questions, right? So
Okay.
let us see this. We'll now explore this identity further since we worked a lot with the sine square x and cos square x in your examples. So in the
Okay.
next set of examples, which we are going to take in the next class, we'll work on more on this. So how I can write this as, look here, I could actually write this statement as 1 equals to secant square x minus tan square x, correct?
Yeah.
Now that is difference of square. So I hope you remember this particular formula. What is a square minus b square equals to? A plus b
Yeah. A plus
times
B.
a minus b, right?
A minus. Yeah.
So that means I could actually write this 1 equals to secant square x minus tan square x
Yeah.
as 1 is equals to secant x plus tan x times secant x minus tan x.
Yeah.
Correct? Now,
Yeah.
that really means what is 1 over, let me divide by secant x plus tan x. That is equals to secant x minus tan x. Do you see that identity?
Yeah.
I could also do the reverse and then I can say, well, secant x plus tan x is equal to 1 over secant x minus tan x. Do you see that? So I could
Yeah.
actually convert it in this particular fashion. That is extremely important in solving very difficult questions. Similarly, this particular
Yeah.
identity also, I could say, well, 1 over cosecant x plus cotangent x is equals to cosecant x minus cot x. Is that okay? And I can also write this as 1
Yeah.
over cosecant x minus cot x is equals to cosecant x plus cotangent x. You see, the Pythagorean identity can be molded in so many different ways. And so that brings us to the last one. Why should we leave this, right? So
Yeah.
one is actually sum of these two. So many times one could be written as cos square x plus sine square x, and you can solve many difficult questions. So writing one in different ways is so important, correct? So what I could say here is that one is equals to cos square x plus sine square x. 1 is also equal to, as you saw, secant square x minus tan square x, and 1 is also equals to cosecant square x minus cotangent square x. Do you see that part? How 1
Yeah.
has related all the 6 squares. Now, since you know such a powerful relation, you can actually equate these and solve very difficult questions on identities very easily. Do you understand this concept, Aryan?
Yeah.
So, Aryan, can you summarize our today's learnings?
Yeah. Sure. Yeah. So basically, in today's class, we went over the different types of trigonometry identities and used a different method to proving them and actually like understanding how to like use these properties.
Correct. So, these properties are not difficult to remember. Now, you remember, I think, almost all of them, right?
Kind of, almost. Yeah.
Almost, right? So, have a good look at this page. So, let's end at this page, which has kind of all the formula which you need at this grade 8 level, right? I mean, it's a grade 11 course for a grade
Yeah.
8 student, right? So, at grade 11, here we do these identities for a normal student. And it's very good that you're doing this right now. So, excellent future for you, Aryan. So, we'll close the class here for now and we'll pick up identities, the next level of identities in the next class. That sounds
Okay.
good?
Yeah. It's fine.
Okay, great. Thank you and all the best.
Thank you.